Hello, geometry students. Mr. Zacek back and better than ever. We are cranking along here in Unit 6, and we're going to focus today on polygons in the coordinate plane and how we can prove things on the coordinate plane. So, a couple thoughts as we get started here. There are when we're talking about the coordinate plane, we're talking about these, x, y points. And we want to think about these. We want to begin with our formulas. And if you are trying to do a proof on the coordinate plane and you don't begin with a formula, you're doing the wrong approach. So we can prove a few different things. And so let's kind of review our formulas here. Number one is the distance formula, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root to find the distance. Take the square root. So what is this going to prove? Well, that will prove that we either have congruent segments or not congruent segments. So we're looking for, if they have the same distance, we can prove that they're congruent, or we could prove they're not congruent if they don't have the same distance. Then we have our slope formula, which is y2 minus y1 over x2 minus x1. It's the rise over run. It's the slope formula. So this would prove parallel or not parallel, but it also could prove perpendicular or not perpendicular. Okay, so same slope we're thinking of with this, or for parallel, is when it's the same. For perpendicular, it's when it's negative reciprocal. So primarily, those are going to be the ones that we do most often, but I will mention the third one, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The midpoint formula, that's for you. You have to add and divide by 2. Excuse me, I had to sneeze in the middle of that. Okay, what the midpoint formula is going to prove is if two segments bisect. So if they both have the same midpoint, then they will bisect each other. All right, so that's our overview. We're going to begin with the formulas. That's how we're going to prove different things here. Okay, now then the question becomes about understanding the properties of these different shapes and what will uniquely prove those. Let's go ahead here and look at question 1. In triangle ABC has vertices, A is 0, 1. So there's A. B is 4, 4. And C is 7, 0. Okay, so this is a triangle. And what we're trying to prove is it scalene, isosceles, or equilateral? So we're really thinking about, the question is asking about the lengths, okay? So scalene, none of the lengths are the same. Isosceles, 2 of the lengths are the same. Equilateral, all of the lengths are the same. So lengths is going to be our distance formula. That's the connection that we want to make. So here's what I recommend. Bring the point into your workspace. These things take a lot of work. A is 0, 1. B is 4, 4. So people make so many errors not doing this. So always bring the point into your workspace. Let's label it x1, y1, x2, y2. So AB is going to be now you notice I didn't put a segment bar over the top because I'm referring to the length or the distance. So it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're telling a story. We need to leave all the parts in here. So 4 minus 0 is going to be 4. 4 squared would be 16. 4 minus 1 would be 3. 3 squared would be 9. So AB is the square root of 25. AB equals 5. If it didn't simplify all the way, you wouldn't have to do that. So AB is a length of 5. I'm going to come over here next and I'm going to do BC. Again, I'm going to bring my point into my workspace visually. B is 4, 4. C is 7, 0. I'm going to new formula. I'm going to call this x1, y1, x2, y2. And so BC is going to equal x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. So 7 minus 4 is 3 squared. 0, that'd be negative 4 squared. Okay. This is going to be, again, 9 and 16, square root of 25. Okay, so BC is going to be 5. So at a minimum, we've got ourselves an isosceles triangle. Let's see if it is an equilateral. It doesn't look like it is, but let's go ahead and prove it. So A is 0, 1, C is 7, 0. So we're going to start off with x1, y1 again, x2, y2. Notice I'm telling the person who's reading this what AB equals, what BC equals. I'm not just randomly doing the distance formula and giving no direction to a person reading this. So we have 7 minus 0 squared plus 0 minus 1 squared. Okay, so we get 49 plus 1, which is the square root of 50, which is not 5. All right, so here's the conclusion that we can make. And this is kind of how, this is the way we do it differently than statements and reasons. So we're going to say that AB is congruent to BC because they have the same distance. So therefore, that's these three little dots are a therefore. Therefore, triangle ABC is isosceles because two sides of the triangle are congruent. Okay, so we tend to in our coordinate geometry things, again, we're going to begin with formulas, and then we're still going to make a statement and a reason, but we're not going to put it into a column format. We're just going to make these conclusions and make a statement and say because. Okay, now is triangle ABC a right triangle? So let's go back and look here. And what we want to think about is with a right triangle, the question we're asking is, do we have perpendicular sides? That's really the question. If they're perpendicular, then they form a right angle. If it forms a right angle, then it's a right triangle. So as I look at this picture, it looks like where that could happen would be possibly at point B, maybe a right angle. So we're going to do the slope. So I'll start with A, which is a 0, 1, and I'll start with B, which is 4, 4. And now I'm going to do the slope formula. Maybe you want to write the slope formula down here, y2 minus y1 over x2 minus x1. All right. And now I'm not going to write AB because I'm not talking about the length. I'm going to write the slope of AB. x1, y1, x2, y2. I'm being very specific with those things. It matters. So 4 minus 1, y2 minus y1 over x2 minus x1 would be 3/4. Okay, so that's the slope of AB. And then I said it looks like it might be with BC possibly. So again, I'm going to bring the point in. B is 4, 4. C is the point 7, 0. I'm going to label this x1, y1, x2, y2. I'm going to write the slope of BC, and it's y2 minus y1 over x2 minus x1. And so we have -4 over 3. Whoa, look at that. You want to simplify those. They are simplified in this case. AB is 3/4, BC, the slope, is -4/3. Those are negative reciprocals. And so we can make a statement that AB is perpendicular to BC because their slopes are negative reciprocals. So, a couple different ways you can go about this there of saying it's a right triangle. So then we could say, therefore, triangle ABC is a right triangle because two sides are perpendicular. Okay, and that would be a sufficient reason there. Okay, so you're going to find with these proof questions on the coordinate plane that there's a lot of work, but the work is more straightforward. There's not as many options. Like when we had other proofs, there was lots more options. Here, it's a lot more about just understanding the beginning parts that I said here about distance, slope, what those things show, and then it's about accuracy. So it's about visual workflow, attention to detail. Those become really critical pieces of this, this type of work. So let's go ahead now and we've got quadrilateral ABCD, and it's got these vertices, and the question is it a parallelogram? So we could go here and I'm going to graph this first, and then we'll talk about some other things. So here's A, B is what, 0, 4, here's B, C would be 4, 5, and then D would be 3, 1. Well, that kind of looks like it's maybe parallel. Okay, so we have to kind of come up with a plan first. All right, so what's our plan? Well, what would be true if it is a parallelogram? So here are some options that we have. Options. I could show both pairs of opposite sides parallel. Okay, that would be one option. Second option would be to show both pairs of opposite sides congruent. A third option would be to show one pair both parallel and congruent. Okay. Now there's other ways. We could show that the diagonals bisect each other. That would be another method of doing it. Yeah, so I guess let's write that down. We could show the diagonals bisect each other. So what you want to do with these different quadrilateral ones is you kind of want to have one method in mind, because we're going to ask about the different quadrilaterals that we have, and you should have a method in mind. Now for me, when I think about a parallelogram, probably my preferred method, the one that comes to me quickly, is both sides of opposite sides are parallel, and I'm going to understand that that would be the slope formula. Okay? If you wanted to do the next one, it would be the distance formula. Number 3 would be slope and distance, and number 4 would be the midpoint formula. So in order to do this, show both pairs of opposite sides parallel, I need to show, I need to find all 4 slopes. So in order to do that, I'm going to find all 4 slopes. That's critical. If we're not doing a formula first, we're not in the right place. So let's go ahead with A here. A is the point -1, 0, and B is the point 0, 4. So I'm going to write my slope formula right here. y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. Again, I'm going to write the slope of AB. Okay, help the person who's reading this have a clue of what you're doing. So we're going to do y2 minus y1 over x2 minus x1. I always put that second one in parentheses. So the slope of AB would be 4 over 1. Now, AB should be parallel to CD. So the next one I'm going to do is CD. So C is 4, 5, and D is 3, 1. So I'm going to label this again, x1, y1, x2, y2, and we're going to call this the slope of CD. So y2 minus y1 over x2 minus x1. So 1 minus 5 is negative 4 over negative 1. Well, a negative divided by a negative is positive. So we have those two. All right. So what I'm going to do now is both of those have the same slope. So I'm just going to make a statement. I'm going to say AB is parallel to CD because they have the same slope. So we did our formula, we make our conclusion, okay? Now, the next thing I'm going to do is I'm going to go ahead and find the slope of the other side. So let's go ahead with BC. All right, so point B is 0, 4. Point C is what? 4, 5. So 4, 5. So x1, y1. x2, y2. I should be thinking of, so the slope of BC is y2 minus y1, 5 minus 4 over 4 minus 0, or 1/4. Okay, now, just when you're doing slope and you have a graph, like, don't get so formula focused that you forget how to count. You go up here and you count over and you count over and it goes up 1 over 1, 2, 3, 4. Okay, so nice simple way to check your work there as you're doing that. All right, and then we have the last one. That side should be parallel to A, which is negative 1, 0. D, which D is 3, 1. So x1, y1, x2, y2. So the slope of AD is going to be 1 minus 0 over 3 minus negative 1, which is going to reduce to be 1/4. So the slope of AD is also 1/4. So we can make the conclusion that BC is parallel to AD because they have the same slope. Now, what does that mean about the parallelogram? So our final conclusion here is therefore ABCD is a parallelogram. Why? Because both pairs of opposite sides are parallel. All right. Now this question has a part 2. Is it a rhombus? Oh my goodness, a parallelogram could be a rhombus. All right. So the way that I would do a rhombus, so when we think about rhombus, we should think about a couple things. Number one, a rhombus has 4 congruent sides. Okay. And then the other thing is a rhombus has perpendicular diagonals. A rhombus also, the diagonals bisect angles, but that's not a relationship that we can show on the coordinate plane, so we're not going to consider that as an option. Now we've already proved that it's a parallelogram, so I'm going to go the route of the diagonals and see if they in fact are perpendicular. So our diagonals would be AC and BD. So let's go ahead and find the slope of those. So A is -1, 0. C is 4, 5. X1, Y1, X2, Y2. So the slope of AC is 5 minus 0 over 4 minus -1. Okay, so that means the slope of AC would be 5 over 5 or 1. And then the other diagonal was, let me just go check, I think it's BD. Yep, so B is 0, 4, D is 3, 1. So again, X1, Y1, X2, Y2. So the slope of BD, so Y2 minus Y1 over X2 minus X1 would be -3 over 3. The slope of BD is -1. Well, 1 and -1 are negative reciprocals. So here's what we could say. AC is perpendicular to BD because slopes are negative reciprocals. Okay, so now what do we have? We have a parallelogram plus perpendicular diagonals. So we can say that ABCD is a rhombus because it is a parallelogram with perpendicular diagonals. All right, now if you're looking for maybe a little, how do I do this question with a little bit less work? The way to do that would have been to have done the distance formula initially. If we had done the distance formula initially, we could have proved it's a parallelogram and we could have gone right into proving that it's a rhombus because we would have found that all 4 sides are congruent. Okay, but this is, another way of approaching that. All right, let's see what we got going on here. We've got a rectangle, and then we got a question of, is it a square? The square ones are probably the ones that are the most, they require the most work. So let's go ahead here, -1, 4. This is going to be our value for n. I skipped m. Hang on, 0, 1. This is going to be m. And then we've got P, which would be 2, 5. Okay, that's going to be P. And then Q, which is going to be 3, 2. Okay, so kind of looks like it could be a square. So I'm going to go about this by, I'm going to show you a little shortcut, okay, on how you can do this. All right, so the question is it a rectangle? So in a rectangle is a parallelogram plus. So a parallelogram plus, methods to prove a rectangle. We could prove a parallelogram plus congruent diagonals. That's one way to do it. Okay, or for a rectangle, if we could show that it has 4 right angles, that would be a parallelogram. So we're going to use, I'm going to show you a different way to use the slope formula here. So what if we did slope as rise over run, and we just wrote it out on our thing here. Now you have to write you have to write it out. So we're going to go up 1, 1, 2, 3. Okay, and then we've got 1 and 3, 3 and 1, 3 and 1. So a little kind of shortcut that you can do for this is to say, okay, the slope of NP is up 1 over 3. the slope of PQ, see now we're going down 3 and to the right 1, so that would be negative 3 over 1. The slope of MQ is up 1 over 3. Okay, so rise is going up 1 over here. The run is 3. And then the slope of NM, we're going down 3 into the right 1, so that's negative 3 over 1. Well, look at that. They're all perpendicular to each other. Okay, so how can we say that? Okay, so we can now say, and the reason is all going to be the same, so we can kind of shortcut this. So NP is perpendicular to PQ. Okay, PQ is perpendicular to MQ. NM, I'll keep working that way. MQ is perpendicular to NM. And NM is perpendicular to NP. I just went around and did all of it, all for the same reason. Their slopes are negative reciprocals. So I made a statement. I said I showed the work. I found their slopes. I made a statement that they're perpendicular, and I gave a reason. Now, what do perpendicular lines do? They all form right angles. So we could say angle N, angle P, angle Q, and angle M are right angles. Why? Because perpendicular lines form right angles. What did I say at the beginning? If we could show that there were 4 right angles, that would prove that it is a rectangle. Okay, so parallelogram MNPQ is a rectangle because it has 4 right angles. Okay, now the next part of this says, is it a square? Well, so to think about square, we need to bring in something from the rhombus. A square is a rectangle and a rhombus put together. So the way that I would do this, and I'm going to show you again another little shortcut here. So the distance formula, another way to think about it is the change in x squared plus the change in y squared. Well, isn't that the run and the rise? Haven't we found that already on our graph? And in fact, we have. So NP, now this is distance. I don't need to write the word distance. I just, okay, what is that? That's the square root of, let's go back up here. How's the x value changing? 3 squared. How's the y value changing? Going up 1 squared, this line right here. Okay, so that's going to be the square root of 10. So the next one, let's do PQ. The change in x, how's the x value changing? Well, it's just going over 1. 1 squared, what's the change in y? We're going down 3. If you want to put it in as negative 3 squared, you can. Sign isn't going to matter because when we square it, it will become positive. So we got PQ is 10. Now we got MQ. What's going on? The change in x, well, that's 3. Change in y, 1. Again, it's not wrong to write all of it out. Okay, I'm just showing you a little bit of a shortcut. When you do it this way, the one thing to note is you have to write it out on the graph. If you don't show it on the graph, then you're not showing your work. So here the change in x is 1. the change in y is 3. Okay, so nm is 10. All right. Now, what does that mean? Well, that means all 4 of those sides are congruent to each other. So np is congruent to pq, is congruent to mq, is congruent to nm. Why? Because they all have the same distance. So what do we have going on? Well, we've got a quadrilateral with 4 congruent sides and 4 at angles. That's a square. Okay, so we could say MNPQ is a square because it has 4 congruent sides and 4 right angles. All right. Lots of work on that one, okay? So there's a good bit of stuff that we have to do. There's a lot of work. There's a lot of detail, okay? But again, remember, we're always going to start with a formula, and then we're going to make a conclusion from that there, all right? So we're getting into a section now here on our unit where we've got one more short little lesson, and then we're going to do a whole bunch of practice with labs of getting all kinds of these things to really work our understanding in this for us. Okay, so we're going to get a lot of practice here before we have a quiz. All right, let's keep asking questions. I'll see you soon.